So in level 1, we had one variable by itself in both equations. In level 2, we had one variable by itself in one equation. So now we've graduated to level 3, where there isn't a variable that's already by itself. We will have to do a little bit of arranging. So here are our original problems. 4x plus 3y equals 0, and 2x plus y equals negative 2. And we ask ourselves the same question every time, no matter what system we're given. Look at the equations. Is there a variable isolated? No, there isn't. So for the first time, we will have to use this first box here. And in this first box, it says to choose the variable easiest to isolate in one of the equations. Look for variables with coefficients of 1 or negative 1 and rewrite the equation to get an x equals or a y equals before we go on to step 2. So when I look at these two equations, I can see that the x has a number in front in this equation and the y has a number in front in this equation. And in the blue one, the x has a number in front, but the y does not have a number in front that I can see. It only has a 1 in front. So I'm going to attempt to solve for y in the blue equation. 2x plus y equals negative 2. Now, does it mean that it's wrong if you chose the purple equation or that you tried to solve to get x by itself instead of y by itself? No. It just means that you may have a more complicated equation to deal with, one that maybe includes fractions, and you certainly have more steps when it comes to solving the system. So my goal right now is to get y by itself. So we're going to subtract our 2x from both sides. We have plenty of practice doing this from our last standard. So y equals negative 2x minus 2. And now y is already all by itself. So we are going to take the expression that it equals, and we are going to plug it in to our other equation. 4x plus 3y equals 0. We are going to take and plug in this expression for y. So we have 4x plus 3 times, and remember we're using parentheses, negative 2x minus 2, and it equals 0. So to solve this, we need to distribute 4x. 3 times negative 2x gives me negative 6x. 3 times negative 2 gives me negative 6. We have now like terms. 4x minus 6x gives me negative 2x minus 6. And we can add 6 to both sides. Negative 2x equals positive 6. Divide by negative 2 on both sides so that x is equal to negative 3. So we will take that negative 3, and remember it's part of our actual solution. It's x, so we'll put it in the x spot. And we are going to take that negative 3 and we're going to plug it back in for x into one of our original equations. You can choose either the purple equation or you may choose the blue equation. It does not really matter which equation you choose. 4 times, and I'm going to plug in negative 3 for x, plus 3y equals 0. 4 times negative 3 gives me negative 12, plus 3y equals 0. Add 12 to both sides. 3y equals 12. Divide by 3 on both sides, and we have that y equals positive 4, which is the other part of my solution. Let's take a look at another example. So we're going to write our two equations down in our box here. Negative x plus 3y equals negative 9. And 8x minus 4y equals 32. Look at the equations. Is there a variable that's already by itself? No, there's not. But is there one that's easy to get by itself? Because we said no, we have to go here, and we have to find one that's easy to get by itself. This one, x only has a negative in front of it. The y has a number in front of it. This x has a number in front of it. This y has a number in front of it. So it looks like the easiest variable to get by itself is going to be this one right here. So negative x plus 3y equals negative 9, and we are solving to get x by itself. Remember, our first step is to do any addition or subtraction. This is being added, so we're going to subtract 3y from both sides. Now I have a negative 1 hanging out in front, even though you can't see the 1, it's there. So I need to divide by negative 1 to all three parts, giving us x equals 3y plus 9. And we are going to take this expression and we are going to plug it in for x into our blue equation. So here's our blue equation. And we are going to take this expression and we are going to plug it in for x. That's why Mrs. Rodriguez has erasable pens and why I ask you to do things in pencil on quizzes and tests. So I have 8 times our expression that needs to go in parentheses, 3y plus 9 minus 4y equals 32. Now to solve, we need to distribute. So I have 24y plus 72 minus 4y equals 32. We need to combine some like terms. 24y minus 4y gives me 20y. Now we'll subtract 72 from both sides. And we have 20y equals negative 40. Divide by 20. And we have y equals negative 2. Now remember, that is part of my solution, so it does need to appear in the y spot. But we are also going to take this and we are going to plug it back into one of the original equations. So I'm going to plug it back into this equation up here. 8x minus 4 times y equals 32. That equation. And we're going to take this y and plug it in here 8x minus 4 times negative 2 equals 32. 8x negative 4 times negative 2 plus 8 equals 32. Subtract 8 from both sides, and 8x equals 24. Divide by 8 on both sides, and we get x is equal to 3. That's our x coordinate. Now, level 3 also introduces back the idea of special cases. So if you'll turn back to, I believe it's page 2 in your notes, we're going to finish filling out our special cases solutions. The top half of this was all about solving by graphing, and the bottom half is all about solving algebraically, which our last two standards are both algebraic standards. So we have our first one that's talking about how to solve to actually get a point, where we get x equals a number, y equals a number, and that creates our point. But these two talk about our special cases. So you may want to pause the video real quick to copy this down. But in the infinitely many solutions, we will be working a problem out, and all of a sudden, all of the x's will cancel out, or all of the y's will cancel out when you go to combine like terms. And what you're left with is a true statement, like 7 equals 7, negative 2 equals negative 2. As long as your statement is true, your answer will be infinitely many solutions. And if we think back to our first standard when we had to talk about special cases, we knew that infinitely many solutions were the same line plotted one on top of the other. So it would make sense that I would get a true statement. They're the same line, so of course everything works in it. No solutions, you'll still have everything cancel, but what you'll be left with will be a false statement. For example, 4 equals negative 1, 7 equals 3. You'll have a false statement, which means there's no solution. Let's work through an example problem that could be a special case. We'll write down our equations. X plus 2y equals 10, and 2x plus 4y equals 10. So step 1, look at the equations. Do we already have a variable by itself? And we don't. So we have to find one that's by itself. And when I look at the 4 variables, x is the only one that has a coefficient of 1. So that's the one that I'm going to try to get by itself. So we are going to now subtract our 2y from both sides, leaving us with x equals negative 2y and a positive 10. We're going to take this expression and we are going to plug it in to the other equation. So the negative 2y will go in for x. 2 times parentheses negative 2y plus 10 plus 4y equals 10. Now we can distribute. 2 times negative 2y gives me negative 4y. 2 times negative 10 positive 10 gives me positive 20. Let's combine like terms. Negative 4y, positive 4y, those are going to cancel. And then we're left with 20 equals 10. Remember, in our special cases, we said the variables would always cancel. And we have to decide, am I left with a true statement or a false statement? I'm left with a false statement, which means that my answer is there's no solution. That's as far as you have to go. Let's take a look at another example. Write your two equations down. Y equals 3x plus 4. And our other equation, negative 12x plus 4y equals 16. So we ask ourselves, look at the equations. Is there already a variable that's by itself? And this time there is. In the first equation, y is already by itself. So we'll copy these equations down. And we are now going to take and substitute this expression in for y. Negative 12x plus 4 times 3x plus 4, and it will equal 16. We do have some distributing to do. Distribute the 4 all the way across. So negative 12x plus 12x plus 16 equals 16. Time to combine like terms. Negative 12x plus 12x is 0, so they're gone. And we're left with 16 equals 16. This is a true statement. That means that my solution or my answer is IMS, infinitely many solutions. One last example. Write our two equations down. Is there already a variable that's by itself? And there isn't. So we have to follow along. Choose a variable to isolate. We want to look to see, is there an easy one to isolate? Looking at the 4 variables, there isn't one that doesn't have a coefficient written in front. So we have to find something ourselves. My suggestion would be that when you are trying to find a variable by itself, like let's pretend that we want to take this x and see if it's by itself, that you maybe look to see, does 8 go into the other numbers? And if it doesn't, maybe look for a different variable because you're going to end up with fractions. So let's try this one. Does 4 go into 8? Yes. Does 4 go into 20? Yes. So I'm going to solve to get y by itself. Was that the only one that I could have used? No. I could have also done this one. Negative 2 goes into negative 6. Negative 2 goes into negative 16. It still would have given me something that didn't have fractions. So I will take 8x plus 4y equals 20. It wouldn't have been wrong if you decided to get x by itself. It just would have meant that you were dealing with some fractions when you're substituting, which isn't always very fun. So to get y alone, we will subtract 8x from both sides, leaving us with 4y equals negative 8x plus 20. Divide by 4, and y is equal to negative 2x plus 5. We avoided having fractions. Negative 6x minus 2y equals negative 16 is our other equation. And we are going to take and plug in this expression for y. So we have negative 6x minus 2 times our y expression. Negative 2x plus 5 equals negative 16. We need to do some distributing. Negative 2 gets distributed inside here. So we have negative 6x. This becomes a positive 4x. And negative 2 and 5 gives me negative 10. And it equals negative 16. Negative 6x plus 4x gives me negative 2x. We'll add 10x to both sides. Oh, sorry, just adding 10 to both sides. Then we will divide by negative 2, leaving us with y equals positive 3. Now remember, that is part of the solution. So it's going to be put into the first spot of our coordinates. And we're going to take this 3 and we want to plug it into one of the original equations. So we will take this 3 and let's plug it into the blue equation. Negative 6x and minus 2y equals negative 16. And we're going to take this 3 and we're going to plug it in for x. Negative 6 times 3 minus 2y equals negative 16. So to solve this, negative 6 times 3 is negative 18 minus 2y equals negative 16. Add 18 to both sides. And negative 2y equals 2. Divide by negative 2. Y is equal to negative 1, which is the other portion of my point.